Your A330 is equipped with Pratt & Whitney 4000 series engines. Like most engines today, this engine comprises a low-pressure compressor stage, a high-pressure compressor stage, a combustion chamber, and a turbine stage. The low-speed rotor, N1, consists of a front fan and a low-pressure compressor connected to a low-pressure turbine. The high-speed rotor, N2, consists of a high-pressure compressor connected to a high-pressure turbine. The combustion chamber is equipped with two igniters, called A and B. And is driven by the high-pressure rotor. Each engine is equipped with a full authority digital engine control system, FADEC, which provides complete engine management. Each FADEC has two identical and independent channels, A and B. Each engine is equipped with reversers. The engines are controlled by thrust levers, which are located on the center pedestal. These two levers control the reversers. The auto thrust can be disconnected using the two red buttons, which are called instinctive disconnect push buttons. The controls for engine starting and shutdown are located on the center pedestal, just behind the thrust levers. The engine master switch and the engine mode selector enable the pilots to start the engines or simply dry crank them. Once the engines are running, the mode selector can also provide continuous ignition. Each engine has a fire and fault light. This panel will be explained in detail in the normal and abnormal operation modules. On the overhead panel, there is an additional panel which is used for manual start and in abnormal operation. This will be seen later in the manual start module and in the abnormal operation module. For all these controls, indications are displayed on the engine warning display and engine ECAM page. The engines are also protected by a fire protection system. You will see the complete operation of this system in the fire operation chapter. Let's look at what you need to know about the engines during normal operation. We will start with what you see during the preliminary cockpit preparation. First, check that the engine master 1 and 2 are off, that the engine start selector is in the normal position, and that the engine manual start push buttons are off. Let's power the aircraft. Power the aircraft using the external power. After the electrical power is applied, the FADECs are powered automatically and provide some engine indications on the engine warning display. After 5 minutes, the FADECs shut down automatically and all the engine indications change from normal to amber. In order to check the engine oil quantity, we have called the engine ECAM page. and we will power the FADEX again. On the maintenance panel, located on the overhead panel, select Engine FADEC ground power switches 1 and 2 on to energize the FADEX, and check that the oil quantity is at or above 12 quarts on the ECAM engine page. Press Engine FADEC ground power 1 push button switch. Press Engine FADEC ground power 2 push button switch. The oil quantity has been checked on both engines. We will switch both FADECs off for you. Let's now continue with the walk-around for the power plant. On the left-hand side of each engine, we check that the IDG oil fill access and engine oil fill access door is closed, and that the thrust reverser cowl door is closed. We also check that the pressure relief doors are closed, and the fan cowl door must be closed and latched. Verify the condition of the drain masts and the absence of leakage. Also, check that the access to the starter valve manual override is closed, and the access door to reverser latches must be closed. At the front, we verify the condition of the engine inlet and fan blades. On the right-hand side, we check that fan and thrust reverser cowl doors are closed and latched, and verify that the pressure relief doors are closed. Finally, we verify that the turbine exhaust is clear. When the external inspection has been completed, we return to the cockpit for the cockpit preparation. Back in the cockpit, we verify that the thrust levers are in the idle position and the reverse levers are stowed. We will start the engines using the automatic engine start procedure. During the start sequence, all the engine parameters are monitored, controlled, and protected by the FADEX. In order to start the engines, the engine start selector must first be set to ignition start. Switch on the engine ignition start function. When ignition start is selected, the FADEX are powered again. This is indicated on the engine warning display by the indications which change from amber to normal. On the system display, the ECAM engine page is automatically presented and displays all engine indications. Note, after 30 seconds without any actions on the master switches, the ECAM engine page will automatically disappear. Let's have a close look at the displays. The first indications on the engine warning display are the engine pressure ratio, EPR, for each engine. Both indicators are identical. The green needle indicates the actual EPR. This value is also displayed digitally. The blue circle represents the EPR, corresponding to the thrust lever position. The amber mark represents the EPR limit. On the right-hand side of the engine warning display, the thrust limit mode and EPR rating limit are displayed. This will be explained and demonstrated as the mode changes later in the module. The next set of indicators display the exhaust gas temperature, EGT, of each engine. The green needle indicates the actual EGT. This value is also displayed digitally. The amber tick indicates the maximum EGT, max EGT. Since the max EGT is different during engine start, after stabilization, the tick moves automatically to its normal operation position. Note, the amber tick is not displayed during takeoff, when alpha floor is active, or when the reversers are selected. On each side of the EGT indicators, the fuel flow is displayed for the engine. Now let's look at the indications on the ECAM engine page. The first indication available is the fuel used by each engine. Notice that there is an indication of fuel used, and we have not started the engines. This is because this value is frozen at engine shutdown and reset on the ground at the next engine start. The next indications are the engine oil quantity, the oil pressure, and the oil temperature. Vibration indications are displayed below the oil temperature. There are additional indications displayed during engine start on the ground. They are only displayed when the engine start selector is in the ignition start or crank position. They are the start valve position indications and the air pressure available for start. When the engines are started, the start valve indication is replaced by the nacelle temperature. We will start the engines using the available APU bleed, as indicated in the memo, and the pressure indication at the bottom of the system display. We start engine 1 first because the blue hydraulic system engine-driven pump is on engine 1, and the blue system supplies park brake pressure. Switch on engine 1. The corresponding start valve opens. This is indicated by the start valve indication changing from green crossline to green inline. The fuel used is reset to 0. On the engine warning display, N2 increases. It is displayed on a gray background. On the ECAM engine page, the oil pressure increases. When N2 reaches 20%, an igniter is powered. The active igniter is indicated by a letter, A or B, on the ECAM engine page. Note, the igniters alternate on successive starts. The fuel flow begins. When the fuel is ignited, EGT increases. As N2 increases, N1 begins to increase. When N2 is between 43 and 48%, the start valve closes and the ignition is switched off. Notice on the ECAM engine page, the start valve is closed and the igniter indication disappears. The thrust limit mode changes from climb to flex, and today the EPR rating limit is 1.448. Note, flex or takeoff go-around can be the mode used for takeoff. They will be explained later on in the normal operation module B. N2 continues to increase. At approximately 59%, it stabilizes and the gray background disappears, indicating that the start sequence is finished. Engine 1 is now running and all its parameters have stabilized. A veil is displayed steady to indicate that idle has been reached. It will disappear after 9 seconds or as soon as thrust is applied. Note, after a successful engine relight in flight, the veil indication pulses green. It disappears as soon as thrust is applied. On the N1 gauge, the green needle indicates the actual N1. This value is also displayed digitally. The N2 indication corresponds to the second rotor, called high-speed rotor. Let's start engine 2 now. We will show you the full sequence without stopping. Switch engine 2 on. Start valve opens. Fuel used reset. N2 increases. Oil pressure increases. Igniter is powered. Fuel flow begins. EGT increases. When N2 is between 43 and 48%, the start valve closes and ignition is switched off. At about 59%, N2 stabilizes and the gray background disappears, indicating that engine 2 start sequence is finished. For both engines, all parameters have stabilized. The last action is to set the engine start selector to normal. Set the engine start selector to normal. On the system display, the ECAM engine page is replaced by the ECAM wheel page. Note, if the engine start selector is not set to normal, the ECAM engine page is automatically replaced by the ECAM wheel page 15 seconds after second engine start. After starting, to avoid any thermal shock, it is recommended to run the engines at or near idle for at least 3 minutes. Taxi time at idle may be included in this warm-up period. This ends the engine automatic start sequence. In this module, we will see how to operate the engines during the various phases of a flight and familiarize you with their functions and indications. Only a small increase of thrust will get the aircraft moving. Once it is moving, idle thrust is usually sufficient to keep it taxiing. On ground, thrust control is entirely conventional. The thrust lever position determines the thrust. The thrust levers can be moved manually over the entire quadrant. They never move automatically. There are 4 detentes on the quadrant: idle, climb for maximum climb thrust, flex MCT, 1 detente for 2 functions. Flex is used for reduced thrust at takeoff. MCT, for maximum continuous thrust, is used for single-engine operations. Takeoff go-around, for maximum takeoff or go-around thrust. Reversers are controlled using these 2 levers. Idle is the first position. Maximum reverse is the second. Thrust control can be achieved in 2 ways: manually, using the thrust levers, as on any conventional aircraft; automatically, when the auto thrust is active. Let's look at the indications for takeoff. On ground, with engines running, the thrust limit mode is takeoff go-around or flex. The selected mode is displayed in the upper right-hand corner of the engine warning display. Takeoff go-around represents the maximum thrust available from the engine for the actual outside air temperature, OAT. The EPR rating limit, displayed immediately below the selected mode, indicates the related EPR value. Flex is used for reduced thrust takeoff. To achieve the thrust reduction, an assumed temperature, or flex, is used. For example, 45 degrees Celsius. The flex temperature is displayed beside the EPR rating limit. This means that the engines will perform as if the takeoff was made at full power, assuming the OAT at the flex temperature value. As a result, the actual takeoff thrust is reduced, which, in turn, extends engine life. Flex takeoff will be discussed in more detail during the performance part of the course. Today, we will carry out a reduced thrust flex takeoff, since this is what you will do normally. The first step is to move the levers from idle to approximately 1.1 EPR. Click on the thrust levers to apply the thrust. No. To apply the takeoff power, move the levers. When 1.1 EPR is reached, and the N1 value, as soon as thrust is applied, the ECAM engine page replaces the ECAM wheel page on the system display. As soon as thrust is applied, when 1.1 EPR is reached, and the N1 value are similar, flex takeoff thrust is applied on both engines by moving the thrust levers to the flex detente. Continue to apply the takeoff power. No. To apply the takeoff power, move the levers. As soon as thrust is applied, the ECAM engine page replaces the ECAM wheel page on the system display. Note: takeoff go-around thrust is always available by moving the thrust levers to the takeoff go-around detente. At thrust reduction altitude, the thrust levers should be moved to the climb detente to select climb thrust. Select climb thrust. When the levers are in climb position, auto thrust is engaged automatically. The thrust limit mode turns to climb and the EPR rating limit changes. At 1,500 feet above ground level, or 2 minutes after takeoff, the ECAM engine page is replaced by the ECAM cruise page on the system display. Watch the EPR indicators. When the EPR value changes, EPR command arcs are displayed in green from the current EPR to the new EPR value. Let's see it in more detail. Green arcs are displayed between the current EPR and the new EPR value. The green triangle indicates the direction of EPR tendency. Note, all these indications are only displayed with auto thrust engaged. When the new EPR value is reached, all these indications disappear. Let's look at some of the indications on the ECAM cruise page. The cruise page displays the fuel used for each engine, the total fuel used, the oil quantity for each engine, and the vibration rate for N1 and N2. During cruise, descent, and approach phases, auto thrust is normally active and the thrust levers remain in the climb detente. In flight, if both engines are at idle, an idle indication appears. It flashes for 10 seconds and then remains in steady green. Note, there is a slight difference between flight and ground idle. In heavy rain or turbulence, it may be advisable to select continuous ignition. Continuous ignition can be selected manually by moving the mode selector to the ignition start position. Note, in the continuous ignition position, both igniters, A and B, are powered. Select the ignition start position. When selected, the ignition message is displayed on the engine warning display memo. Note, ignition is provided automatically when engine anti-ice is in use. For 10 seconds in the event of engine flameout, or for 10 seconds in the event of inadvertent cycling of the master lever with the engine running. No switching action is required. We are now ready to land. During landing, when reaching the flare, and depending on the wind conditions, the pilot moves the thrust levers to idle. There is an auto call-out to remind the pilot.
Retard, 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 retard.
Select the idle position. After touchdown, reverse is selected immediately to aid the deceleration of the aircraft. Note, thrust reversers are hydraulically actuated. Apply the reversers. On the EPR indicators, reverse appears in amber, indicating that the reversers are unstowed or unlocked. Note, reversers deployment requires one FADEC channel operating aircraft on ground, thrust lever in reverse position. When the reversers are fully deployed, the reverse indication changes to green. Select maximum reverse. As the aircraft speed approaches 70 knots, the levers must be moved to reverse idle. Return the levers to reverse idle. At taxi speed before leaving the runway, the reverse control levers should be stowed. Stow the reverse. We are at the gate. After an engine cool-down period, it is now time to shut down the engines. To do that, the corresponding engine master switches must be switched off. Note: if continuous ignition was selected for landing, switch the engine start selector to normal position prior to engine shutdown. Switch off Engine 1. Engine 1 shuts down. On the engine warning display, the fuel flow indication is 0. The EGT decreases. N1 and N2 decrease. Switch off Engine 2. Engine 1 and 2 are shut down. This sequence ends the normal operation of the engines in the different phases of flight. We now will see how to start the engines manually. There are several reasons why a manual start may be required, including low pneumatic pressure. The main difference between a manual and an automatic start is that the pilot controls the time at which fuel and ignition are supplied to the engine. The FADEC only provides passive monitoring of the engine during the start sequence. This means that responsibility for preventing an over-limit start remains with the pilot. Note: manual starts are completed using the procedure detailed in FCOM 3, Procedures and Techniques. The FADEC controls the closure of the start valve and ignition cutoff on the ground when N2 is between 43 and 48%. If the EGT limit is exceeded, the FADEC automatically aborts the start. On the engine warning display, all indications related to the engines are displayed in amber as long as the FADECs are not powered. First, in order to start the engines, the engine start selector must be set to the ignition start position. Set the engine start selector to ignition start. When the selector is in the ignition start position, the FADECs are energized and the engine parameters are displayed on the engine warning display. The ECAM engine page is displayed automatically. Note: after 30 seconds without any actions, the ECAM engine page will automatically disappear. We will start Engine 1 using the APU bleed. The engine manual start push-button switches control their respective start valves. To start Engine 1, raise the guard and select Engine Manual Start 1 push-button switch. Start Engine 1. On the ECAM engine page, the corresponding start valve opens. On the engine start panel, ON illuminates blue on the Manual Start 1 push button, indicating that the start valve has opened. On the engine warning display, N2 increases. On the ECAM engine page, the oil pressure increases. N2 continues to increase. When N2 is at maximum motoring speed, 20% minimum, set the Engine 1 master switch to on. Switch on Engine 1 master switch. On the ECAM engine page, the fuel used is reset. Both igniters are on. On the engine warning display, fuel flow is indicated. When N2 is between 43 and 48%, start valve closes and ignition stops. Switch off Engine 1 manual start push button. N2 continues increasing. At about 59%, it stabilizes and the gray background disappears, indicating that the start sequence has finished. Engine 1 is running and all its parameters are stabilized. The manual start sequence is finished. If required, Engine 2 can be started in a similar manner. This is a demonstration of an in-flight loss of EPR mode. If no EPR is available, sensed or computed, the affected FADEC will automatically revert to N1 mode. Depending on the failure case leading to EPR mode loss, the FADEC will revert to either rated or unrated N1 mode. You are the pilot non-flying. You are in cruise. Everything is normal. Click on the forward arrow to activate the failure. The amber warning and associated checklist are displayed on the engine warning display. Read the title of the failure. When EPR is lost, the auto thrust is lost. The EPR indicator is amber, and the value is crossed amber, showing that Engine 1 EPR mode is lost. The actual N1 is shown both numerically and by the needle in green. The needle and the numeric value become amber when N1 is greater than the N1 maximum. They become red when N1 is greater than 100%. The blue circle indicates the thrust lever position. This blue circle is not displayed in unrated mode. The amber index indicates the full forward position of the thrust lever, N1 maximum. N1 maximum is not displayed in unrated mode. Let's assume that the levers have been moved and the auto-flight failure has been cleared. The pilot flying will ask you to perform the ECAM actions. Please, perform ECAM action. On the engine panel, the Engine 1 N1 mode push-button switch, blue on light, illuminates. Continue ECAM action. Engine 2 EPR indication turns amber indicating that the EPR mode is lost. The N1 indications are now the same for both engines. The EPR limit mode is replaced by a specific N1 mode limit box, showing clearly that the engines are controlled in the N1 mode. In unrated mode, the N1 mode and N1 limit are crossed amber. The next action is to adjust the thrust manually. Assume this has been done. The procedure has been cleared for you. ECAM actions complete. Let's look briefly at some other engine abnormal indications. Click on the forward arrow to activate the failure. The amber warning is displayed on the engine warning display. Read the title of the failure. On the system display, the ECAM engine page is automatically displayed. The oil filter clog indication is displayed in amber. The same kind of message can occur with the fuel system. The amber warning is displayed on the engine warning display. Read the title of the failure. On the system display, the ECAM engine page is automatically displayed. The fuel filter clog indication is displayed in amber. This is a demonstration of an abnormal engine start. Start engine 1. No. To start engine 1, switch the engine mode selector to ignition start. Continue the start sequence. As there is no ignition, the caution is activated and the amber warning and associated checklist are displayed on the engine warning display. Read the title of the failure. On the engine panel, the fault light illuminates amber, indicating that the automatic start is aborted. Automatically, the FADEC shuts off the fuel and turns off the ignition. After 30 seconds of dry crank, a new start is launched. Igniters A and B are powered and the fuel flow begins. The new start also has aborted. On the engine warning display, the new command line asks you to switch off engine 1. The pilot flying will ask you to perform the ECAM actions. Perform ECAM action. When the engine 1 master switch is off, the message disappears on the engine warning display, and the fault light is switched off. We will assume that the procedure is complete. Now let's see another engine abnormal operation. You are the pilot non-flying. Everything is normal. Click on the forward arrow to activate the failure. The red warning and associated checklist are displayed on the engine warning display. On the system display, the ECAM engine page is automatically displayed. The Engine 1 oil pressure indicator is displayed in red, indicating that the oil pressure is too low. The procedure is to shut down the faulty engine. You will practice this procedure in the simulator. We will assume that the procedure is complete. Now let's see another engine abnormal operation. You are on ground. Everything is normal. Click on the forward arrow to activate the failure. The amber warning and associated checklist are displayed on the engine warning display. Notice that we are operating in very cold weather. Observe the oil temperature is still displayed in green. The procedure instructs you to delay takeoff. The engine should be warmed up prior to takeoff. When in hot climates, observe that the oil temperature increases. The indication pulses above 167 degrees Celsius and becomes amber if the temperature exceeds this value for more than 20 minutes. Observe that if the oil temperature continues to increase, an ECAM caution is activated above 177 degrees Celsius, and the oil temperature indication becomes amber. We will look at some examples of other abnormal indications which can be displayed on the engine warning display and ECAM engine page. During the start sequence with the start valve opened, if the upstream bleed pressure is below the normal range, the indication becomes amber when N2 is greater than or equal to 10%. Note, this may happen during start, but the pressure usually returns to normal. If the pressure remains low, await ECAM instructions. The alpha floor function was explained in the autoflight chapter. However, observe that the engine indications are unusual, as the achieved EPR is greater than the thrust lever limit EPR. We will see a demonstration of an engine EGT overlimit in cruise. You are the pilot non-flying. We are in flight and everything is normal. Click on the forward arrow to activate the failure. On engine 2, EGT value is increasing. On engine 2, EGT value continues to increase. Above the normal range, the EGT indication turns amber. The amber warning and associated checklist are displayed on the engine warning display. Read the title of the failure. The temperature has continued to increase. The EGT indication has turned red. The only ECAM action is to move the thrust lever. We will do this for you. The EGT Engine 2 value indication changes from red to green. We have cleared the procedure for you. ECAM actions complete. A red strip appears at the max reached value. It will disappear after a new start on ground or a maintenance action. A similar indication will be displayed in case of N1 or N2 overlimit. For N1, the indications become red above the max permissible N1. A red mark appears at the max reached value. It will disappear after a new start on ground or a maintenance action. For N2, the indications become red above 100%. A red cross is displayed beside the indicated value. It will disappear after a new start on ground or a maintenance action. We will see now some other engine abnormal indications on the engine warning display and ECAM engine page. An amber check engine warning display message is displayed each time there is a discrepancy between EPR, N1, N2, EGT, or fuel flow values displayed and the real values. When an N2 value is degraded, the last digit is dashed in amber on the corresponding indication. Another abnormal indication can be displayed on the ECAM engine page. The start valves are displayed amber when they are abnormally open or abnormally closed. Finally, for the engine warning display and the ECAM engine page, when one parameter is invalid, two amber crosses replace the associated digital indication. On the engine warning display, for EPR, EGT, and N1 parameters, the needle and the digital display disappear. On the ECAM engine page, the needle is removed on the oil quantity, oil pressure, and nacelle temperature indicators.